section is about concavity inflection point, so we are not going to do concept anymore. I am going to show you how to find the concavity and inflection point of these two given functions using these 4 steps. So speaking of the steps, I am not going to read it off. If you want to keep a record of this, you can take a screenshot right now and then write this down yourself. So I will go over these 4 steps as I am solving a problem. So first, number 1, we have f of x equals to x to the third minus 9x squared plus 24x minus 18. So speaking of concavity, every time you hear the word concavity, what do? You have to think about the second derivative. So to save your time, I already completed the derivative for you. So we can save a little bit more of time on taking derivative, and then I spend more time in discussing concavity. All right, so first f prime of x. So that is 3x squared minus 18x plus 24. That is not a tough job to you, right? And then second derivative. So this one is a 6. I will take the derivative anyway. So 6x and then minus 18. When you have a more higher degree polynomial, put the second derivative in factor form because you have to set that equals to 0. This one is just a linear function. It's simple, but you don't always get a linear function every single time. So set that equals to 0. So what is the critical number? So critical number is what? Is x equals to 3, right? So if you have a x equals to 3, you toss that on a number line, you cut this line into 2 intervals. The first one is from negative infinity to 3. The second one is from 3 to past infinity, all right? And then the second step is you have to set up a table to test each interval, right? So here is what I'm going to do. I am going to write intervals and test value. I will tell you what it is, and then testing the f double prime of x, and then you decide the concavity. All right, so let's draw a nice table. All right, so the first one is from negative infinity to 3, and then the second interval is from 3 to positive infinity. So what is test value? Test value is I want you to pick a value between the upper limit and the lower limit. Pick something easy. So this one, I'm going to pick x equals to 0. You can pick x equals to negative 10 million. As long as the test value is in the interval, you will be okay. But if you pick negative 10 million, then you have a tough time when you plug it in into f double prime. So always pick something easy. X equals to 4, and then you test f double prime of 0. So f double prime of 0, that is 6 times 0 minus 18, that is equals to negative 18. Actually, I don't care what that equals to. All I need to know is that a positive or negative. So negative 18 is less than 0, is negative. So the function is concave down in that interval. X equals to 4, f double prime of 4, so that is 6 times 4 minus 18, that is greater than 0, so the function is concave up. And then concave up to concave down to concave up, and then there is an inflection point. So this is concave down, and then this is concave up. So from down to up, the concavity changes at x equals to 3. So x equals to 3 is an inflection point. X equals to 3 is an inflection point. So therefore, from negative infinity to 3, the function is concave down. And then from 3 to positive infinity, the function is concave up. All right, and then can you tell me where the inflection point is? I am looking for the xy coordinate of the inflection point. What do? Take a second to think about it. I am looking for a location, the location of a point. Where do you plug in the x equals to 3? Please don't tell me that you plug it in into the double prime or the single prime. No, you plug it in back to the original function. So that is 3 squared, right? Or 3 to the third power, you plug it into the original function, the f of x. So minus 9x squared plus 24 times x minus 18. So that equals to 0. So that means 3, 0 is the location of inflection point. So we have 3 comma 0 at a point. So when x is less than 3, the function is concave down. And then when x is greater than 3, the function is concave up. So the shape of the function should look something like this. All right, the next problem is number 2. So let's move on to number 2. We switch color for number 2. So number 2, we have f of x equals to x times x minus 4 to the third. All right, how about this? Let's practice the derivative anyway. So f prime of x. So this one is using what rule? This one is using a product rule, right? fg prime plus gf prime. So that is x times 3x minus 4 squared. The derivative of x minus 4 is equals to 1 using chain rule. And then plus xg and then f prime. The derivative of x is equals to 1. And then this one you will have to clean that up. Then we have a 3x x minus 4 squared plus x minus 4 to the third. 1 raised to the square, 1 raised to the third. So let's factor our x minus 4 squared. And then inside the square bracket, you have 3x and then plus x minus 4 raised to the first power, right? And then you clean that up. So you have x minus 4 squared times 3x. 3 plus 1 is equals to 4. So this will be a 4x minus 4. So that is your first derivative. I highly recommend you to put this in a factor form. So in this factor form, so that gives you an easier time when you find the second derivative. So since everything is based on the second derivative, you don't want to make a mistake on this. If you want to make a mistake on this, the entire problem is wrong. And then f double prime of x. So this one is another product rule, fg prime plus gf prime. So you have x minus 4 squared. The derivative of the square bracket is just a 4. And then plus g, 4x minus 4. The derivative of the square, that is 2 times x minus 4 times 1, right? And then you factor as much as you can. So this is a 4x minus 4 squared plus, and then plus, so this one we can factor our 4 in here, right? Here we can factor a 4 out, right? So the 4 times 2 will be equals to 8. And then you have a x minus 1 times x minus 4. So you have a x minus 1 times x minus 4. Can we go further? Yep, we can factor out at x minus 4. And then you have a 4 times x minus 4. And then plus 8 times x minus 1. And then you clean up the square bracket. So overall, you have x minus 4 times 12x minus 24. And then this one, you can factor out 12. So that is 12 times x minus 4. And then x minus 2. I put this in factor form because I have to set that equals to 0 and then solve for x. If you don't put it in a factor form, you will have a hard time in finding x. So that means we have x equals to 4 and x equals to 2, right? So they are my critical numbers. So critical numbers. So they are my critical numbers. So now we have two numbers. They are going to cut the interval into 3 pieces. So let's draw a number line. We have a 2, we have a 4. So we are going to get 3 intervals from negative infinity to 2, and then from 2 to 4, and then from 4 to positive infinity. This is infinity, by the way. And then you draw a table. So the table, we are going to have intervals, and then test value, and then double prime, and then concavity. Drop the intervals down from negative infinity to 2, and then from 2 to 4, and then from 4 to infinity. And then pick a test value, pick something easy. So let's say x equals to 0, x equals to 0, x equals to 3, and then x equals to 5, and then you plug it in into the double prime. The double prime, you can try this one. So this one is your double prime. So the double prime is right there. So that is your double prime. You plug in f double prime of 0. So f double prime of 0, you are going to have a 12, 0 minus 4, and then 0 minus 2. So overall, you get a positive, right? So negative times a positive 12, you get a positive. And then plug in an f double prime of 3. So 3 right here, and then 3 right there. So this one gives you a negative. And then the last one, f double prime of 5, you plug it into the x right here, and then right there. So 12 times 5 minus 4 times 5 minus 2. So the product of 3 positive is positive. Again, I don't need to know what that equals to exactly. All I need to know is negative or positive. So positive is concave up, negative is concave down, and then positive is concave up. So the graph looks like this. So concave up, and then concave down, and then concave up. So since the up and down changes at this point and then at this point, so we have x equals to 2 and x equals to 4 to be my inflection point, right? So overall, we have concave up, so that will be from negative infinity to positive 2 and from 4 to positive infinity. And then concave down, we have from 2 to 4, and then at x equals to 2 and x equals to 4, we have an inflection. So f of 2, because we are looking for the location of the inflection, we have to plug it in into f of x, f of 2 and f of 4. So that is equals to what? That is equals to x times x minus 4 raised to the third power. So this is a 4 times 4 minus 4 raised to the third power. And then this is a negative 16. This is 0. So you have 2 points. So 2 comma negative 16 and 4 comma 0. They are my inflection point. And then these 3, they are not a point. They are interval. So that is the answer of number 2. So in the next video, I will introduce a couple more examples. I'll see you there.